We're live.
All right. Well, hello everyone, and welcome to another edition of Flake Finder Fridays. My name is Dan Mangum, and I'm here with Rob Kielty, and we are Kubernetes contributors. And I'm a tech lead for SIG Release, and we both served on the CI Signal team. And basically, the purpose of this show is for us to walk through a little bit of how Kubernetes testing is set up. Particularly how it's run in CI environments and how Test Grid and all the different tools work together to give us good signal to know that we can provide a stable release to Kubernetes consumers. But today, we're going to be specifically looking at reproducing flakes and failures on your local machine. And Rob is going to run most of it and look into a specific flake that we saw recently. And we're not actually going to go into addressing that in depth, but we are going to talk about how that could be reproduced locally. And Rob's actually going to do that because he's now a local end-to-end test wizard in my approximation. So I'm going to pass it off to you, Rob, and let you run the show today.
Sure. Thanks for that big introduction. Really appreciate it. The wizardry is only recently acquired, so do have to bear that in mind. I'm just going to share my screen, and I'm going to have to get rid of that and pull that down there. And desktop 1 is not what we want. It's desktop 2, I think. No, it's desktop 1. Now that does not make sense. I think that does make sense. Okay. Okay, let's have a little look here. So can you see my tmux there?
I can see, yeah, I can see it now. I
Yeah.
can see your
Okay.
entire bank account history is what I can see.
Excellent. That's excellent. Yeah. There's not much to be reading there. So let's have a look. So basically what I want to do is I just want to trace through the path of looking at a flake in test grid and drilling down from seeing that in test grid to getting through to code and getting through to running that and trying to reproduce the flake. So there is let me just see here now. I'll just go to the start of my notes. Okay, so essentially, we're going to pick a particular issue. It's the volume teardown and container start can race while a pod is being deleted and report an error. So there's an issue here that was reported before Christmas. It's not a very severe issue, and it's kind of like the edge of a corner of an edge case. And we'll just click on this link here and we'll just have a quick perusal of the issue. I probably already have it there on a tab, but there's no harm in loading it live. So this issue here is this test is checking to see if you stop and start a container repeatedly. There's an issue where in the process of starting and stopping, a secret volume is not mounted, and when a second GoFunk is trying to bring up the container, an expected a volume mount isn't present, and that causes an error. And it's as far as errors go, and the errors that we're interested in CI signal, this is what's referred to as a flaky issue. So for the most part, it works, and then intermittently it fails. And I think I have what that looks like here. So this is the end-to-end job that we're looking at, GCE Ubuntu Master Default. And we can see that for the most part, this test runs successfully and passes, but every now and again it fails. And what I want to do here is just go from this line item in test grid, which I filter down to just cover this test. And I want to look at this string here and then just figure out how we go from this string to see where we can get to the test and code and how we can run that on a local cluster. So we can see that and we were talking about this sort of in tech rehearsal, that this issue here is it's a big long string. We've a Kubernetes end-to-end suite. It's part of SIG node. We have pods extended, then we have pod container status, and the assertion is it should never report success for a pending container. So the first thing I want to do is just go from here and find this in code. And if I hop onto my dev box here and Control B4 to get onto my Emacs, this is where we are on code. So if I just do slash equals equals equals. So the one thing I just want to point out here is that we are using a framework here called Ginkgo, and that is what's doing our what drives our end-to-end tests. And what we have here is a Ginkgo.describe, and what that does is it's difficult for you to read this, but the describe blocks allow us to organize our specs and the test specifications, and this Ginkgo dot it, or in this case fit, I'll explain that in a second. So this is the assertion that we're making in this test. And we can see here that we have Ginkgo it should never report success for a pending container, and this is the end string of what we see in test grid. So that should never report success for a pending container. This is, I suppose, actually the actual test that we're looking at. Now,
Rob, just to jump in for a second, could you mention also where in the Kubernetes source tree this file lives?
Sure, absolutely, yeah. So if I just do a Control XF here, and I'll just open this directory. So if we look at this, the directory that I'm in is in my checked out fork of the Kubernetes repo. So that gets checked out into, that's my home there, home or Kielty, and then we have go source Kate's Kubernetes, and then in the test folder we have an end-to-end folder, and then we have node. Now, there are a couple of traps here. I don't want to get too much caught in the weeds, but if we go up into test, you can see that I think if we go into test, we can see we have end-to-end. We also have end-to-end node, and that was something that kind of tripped me up when I was going through this earlier on in the week. And there are other tests in here. But the tests, I know from hunting around and looking for that string in my code base and in my fork, that our test is actually in here underneath the pods directory.
Yeah, and that's the main thing I wanted you to point out there is the end-to-end directory, right? And we'll make this distinction a little bit later on as well, is for Kubernetes end-to-end tests. And then this is a Kubernetes end-to-end test that is owned by Signode. There's also node end-to-end tests, which are pretty much exclusively owned by Signode. I believe there might be some Sig storage in there, but that's for running specifically against a Kubernetes node.
And so you do have to hunt around and to find tests that are referenced in test grid. And of course, we always have to remember that if you get stuck during the hunt, Slack is always there, and you can always ask questions in either the node room or the Sig testing room. You should get some help on that. I'm just noticing that I'm getting a lot of noise at the bottom. I'm just going to get rid of that noise. Space tab is the last button. Control XB. The editor that I'm using here is Emacs, and it's a particular distribution of Emacs called Spacemacs. And I have a tool here called Kubernetes Overview that allows me, or it should allow me to visit a Kubernetes cluster and look at pods and nodes and logs. But there's a bit of configuration to do on that, so I'm just going to kill that so to get rid of that noise. I'll kill that as well, and I'll kill that too, and that too, and that too. Okay, so this is back to the test. Okay, so this is the code that I needed to that I wanted to run this individual test on. I added that log. You can see possibly in the Git gutter there, and that plus sign. This is a log that I had just to make a change to the test. And I'll just hop over to how I bring up the local cluster. So Control BZ on this. So here you can see that I'm in go source Kate's Kubernetes, and I'm in a detached head state at the moment. In order to bring this up, what I need to do is, and I'm just been included there by Kubernetes by the Zoom there. So in order to run up a local cluster, this is the command that I need to run. So I need to run it as root in order to get access to everything that I need to get access to. I think it's specifically a socket. And the other gotcha is that I need to introduce my path into the path of the command run by sudo. So that's why I have path is assigned $path. for some reason -e doesn't work, but hack/local up cluster.sh will bring up a local cluster. And I suppose the thing to note here is that so the NSA knows my root password now, but in order, I need to run this command from, I need to run this from the root of my Kubernetes checkout. So that takes a few moments for it to come up. When it does come up, we'll get a bunch of instructions that we need to take heed of in order to run the test. So this shouldn't take
Rob,
too long.
one
It
note
takes
here.
about a minute or two.
I think your Zoom config or your Zoom bar is hovering in the middle of the screen for
Let
us.
me see if I can pull it out. That's gone there. Is that better?
Yeah. Can you click the green box and drag it off? Oh, you did. Okay, cool.
I did.
Looks
Yeah.
good.
I think there's a bit of a delay.
Yeah. Looks good.
Getting those bits across the Atlantic now. So this is this info at the end of this. So you leave this running, and then in another pane you can begin to make use of this cluster to run end-to-end tests. And there's a couple of instructions here. So the first thing is it tells you where all the log files are, and that's those there. So it's possible then to Control B to, oh yeah, I'm already done that, haven't I? It will be possible then to tail that. Then this is what you need to run in order. The cluster/kubectl.sh is what we'll be using to, let me just see, to interact with the cluster that we've brought up, and we'll need to export kubeconfig to point to var run kubernetes admin.kubeconfig. So I pretty much have most of that already set up, and I'm just going to go to my pane where I have where I've been running the test, so you can see previous runs there. So I'm just going to Control L there to get rid of all that noise. Let me just see if this will run. So Cubetest --up--test and test args. The test args flag there that passes parameters into the Ginkgo test runner. So Cubetest will ultimately call the Ginkgo CLI to run the tests that we're interested in. And what I want to do here is I want to instruct Ginkgo to focus on the following. This is actually is interpreted as a regular expression, this string. And because this is the test we're interested in, never report success for a pending container, I should only run that test. So I'm just going to pull the trigger on that. And we can see this run. And this is indeed the test running. So, are about to run.
Is the up argument, and we can look at the docs in a minute as well. Is it required since you already have the cluster running? Is it bringing up does it recognize that there's already a cluster there?
I think it might do, yeah, because otherwise it would have taken a time to bring up the cluster. So we could Control C this and take it out to see if it still runs, because I think it might. But
Gotcha.
You can see that because this test is up and running, and I can see also, I'm just going to Control S on that just to pause the output. Oh, that may or may not work. It didn't. No, that didn't work either. But that double equals there test change. That's my log line there, and that I introduced just to make sure that that I could do that iteration of changing the test to see my changes. So this is the test running, and it's stopping and starting pods repeatedly, doing that and checking the status. I suppose the sad part of this is today we're not going to fix this, and it really is the corner of an edge of a corner case, which I think is why we're officially ignoring this for the moment. But that's the test running. If I was to go to go to here and run get pods, we can see that the test in action with respect to bringing up and taking down pods, and you can see that there's a set of terminating and pending starting pods, and this is where the race occurs, is between the stopping and starting of pods, and that's the test in operation.
Yeah, another important note here, right, is this is dependent on the container runtime you have running as well, because that's what's actually handling some of the setup and teardown, and that's why we're having a race, because we're basically, deferring these things to the container runtime and then executing some things in parallel. And sometimes there can be a race with that. One of the things that might be interesting to point out is in that test body there, the way that this is not flaking right now, which this is generally not a way to handle a flaking test. But because Rob mentioned, right, that we are aware of what's happening here, this regex up there is actually ignoring the specific error that was causing the flake, because this is very much an edge case.
But I will say this, though, beautifully done by Jordan, because I mean, the variable name calls out the bug number. So the bug in question, if you go to Kubernetes issues, it is indeed 8766. So in terms of leading the Hansel and Greteling breadcrumbs behind him, he's done a nice job here. Like there's if we were to go down here, and I've effectively in my local. Let me just do RE. Is it REB? Is it REB? Yeah. So on line 367 there, the code, so T is the status. If we look at the definition of T there, it's just a few lines above. Yeah. So at the top of that buffer there, T is assigned status.state.terminated. And here in this case, we are checking to see the exit code, and this is where we get into the meat and two veg of this test, and this walk away from, I suppose, that if the message matches that regex, Jordan is noting it on that line there, 369. So pod on node failed with symptoms of, and then there's a URL to the actual issue itself. So you can't say fairer than that in terms of them, in terms of being self-documenting. And then what I did was, just to force this, was to, instead of just logging it, I returned a fumped error F, and that forced the error. I suppose to wrap up, there's one final thing here that I want to point out and just talk about, because I only learned this yesterday, is that it's possible to instruct Ginkgo to continuously run a test until it fails. So one of the insidious and annoying things about a flaky test is the fact that it mostly passes, and when you're trying to chase something down, you want it to fail. So it's possible to continuously run a specific test or suite of tests until such time as it fails. And I'll just maybe have a quick look here and speak to that. So here, so going back to where I've run this, we can see that those tests, we ran 3 tests, they all passed. And if I do this export here, and I'll just bang that up to there, and export Ginkgo until it fails is assigned true. Yeah, that works. Sometimes fish gives out about export, and sometimes it goes, yeah, I'll take it. But if I run this now, and let's just drop the up and just see if that works. Yeah, it does. Yeah. So this run now will continuously run until such time as this fails. And when I did this yesterday, I think it failed within an hour, but it continuously ran the test until it did fail.
Right. Nice. Yeah, that's one of the most helpful aspects of troubleshooting a flake, right? Continuing to run it until it fails, because it is just kind of like, by definition, a flake, right? So you're not going to see it every time, or in some environments it may show up, sooner or more frequently than others, and especially in one where it's something that's on the other side of an interface from Kubernetes, like with the container runtime here.
Absolutely, yeah. And herein is, I presume where the trickiness here is, because people have looked at this and had a crack at fixing it, but there is that I can almost see it as visualize it as a matrix of threads of execution that are interacting with other components, and you can see how they get a bit confused at times,
Yeah, if
So I
you look
think
at that issue, it's actually pretty helpful for. It's just like an interesting thing to look at in terms of how the
mm,
kubelet looks in the container manager. So definitely would encourage folks to take a look at that. And then, one of the things about the functionality like this being tested at the end-to-end level rather than the node end-to-end level is that we're operating at the Kubernetes API level, like Rob was showing just a moment ago. Those pods being created and deleted and created and deleted. Underneath, right, that has to do with the containers and the mounts, which might be something that we test more at the end-to-end node level. But we still see this behavior that's manifested at that level up when we're interacting with the Kubernetes API, which obviously is what users of Kubernetes are experiencing as well.
mm.
Cool.
I think that's me. I think that's me on this.
Awesome.
Unless you have any other questions.
Well, I know that we have a few folks in the chat at this point, including Ricardo and Adolfo. So thanks for joining, folks. If y'all have any questions, especially on what Rob was going through there, while I'm going to take over and look at CI a little bit, definitely feel free to drop it in there and or in Slack, and Rob can monitor that. But I am going to go ahead and steal the screen from Rob here. And Rob, can you just verify for me that you can see the HackMD I have up here?
I can indeed, yeah.
All right. And as I mentioned at the beginning, per usual, we will share this document and all the links that are in it, which there are copious links in here at this point, and this section will be populated with some more of Rob's stuff.
There's one shout out that I'd like to give is that on the HackMD, we've linked to that an export of that org file that I worked through, and that the big shout out that I want to give is that if you're coming to this as a new contributor or a new test maintainer, the community repo and you're driving to it there now, then Dan, that's great. SIG testing is the folder where I am working from to get through all of this, and it's end-to-end tests. So this so this is end user documentation for running end-to-end tests. And by end user, I mean test maintainer. You may be tempted to go, and you can absolutely go if you want a deep dive on this. You can go to where the source for Cubetest, and you can look at documentation around that. But that's geared more towards maintainers of the tools, whereas this documentation here is for end users of these tools.
Yeah, absolutely. That's a great point. And there's lots of documentation around Cubetest here, which, Cubetest is really just kind of like a friendly interface kind of for interacting with some of the scripts that are in the Kubernetes repo. So definitely take a look at this. Like I said, it is linked here at the run Kubernetes end-to-end test. There's also a separate one for Cubetest 2, which we're going to talk about in a few moments. And then there's also how we noted that there are separate end-to-end tests and node end-to-end tests. If you're more interested in the node end-to-end tests in the same level directory at the SIG node SIG here, we have some documentation on node end-to-end tests and how those can be run. Once again, those are testing at the individual node kubelet level there. All right. So I'm going to, Rob demonstrated how, you can potentially reproduce a flake locally. And I want to look at the same test we are looking at there, but instead look at how it's running in CI, right? Because even if you can reproduce something locally, there may be certain constraints on doing that, or, there may just be that the environment is literally different, right? It's not going to look the exact same as the CI environment. So it's useful to understand the differences between the two, because that may inform if you can produce a flake locally, or, if there's a reason why it's only happening in CI. All right, so I'm going to hop over to Spyglass here, which we talked about on our first episode. So you can go back and take a look at that if you like. And this is a instance of a test failure. So you can get here from test grid, just like Rob had up moments ago, by clicking on one of the little red boxes for this job. You can see this is not actually the same test failing on this one, but I just want to look at this job in general here. Quick tour of Spyglass. Won't reiterate too much of the stuff we talked about last week, but you can see the name of the job here, job history up at the top. Proud job YAML artifacts is basically all of the different artifacts that can come from a job run, and then test grid, which will link you back to the view that Rob was looking at earlier. You'll see this is actually on a different dashboard. Jobs can exist on multiple dashboards, so this one defaulted to going to the Google GCE one. This is also on SIG release master informing. You could access the same exact view on either one of them. Okay, so looking more into what the actual environment we're running this in and how that setup differs from when we're running it in a local environment. Well, the first thing to look at is definitely the proud job YAML. So this is the configuration for this job. All job configuration lives in the test info repo, but you can get a quick link to it from Spyglass for a specific job that you're looking at, just to show where this actually lives in test infra. Excuse me. Here is a link to the job. So you'll see it's in test infra, config jobs, Kubernetes, SIG cloud provider, GCP, GCE example. And you'll see that the name matches. And you'll also see that we have all of those different dashboards that we want it to show up on here reflected in the test grid dashboards. We also have the test grid tab name. So if we were looking back at test grid again, you'll notice that it doesn't say CI Kubernetes end-to-end GCI GCE. It actually has a more friendly name. And then something I'd really like to call out here as a wonderful thing that the test maintainers did here, the config maintainers here did, is they gave a description. So this is super helpful. If you're familiar with some of the test infrastructure already, you may be able to understand this just by looking at the image and the arguments that are being passed and that sort of thing. But it's always helpful just to be able to look at the description and say, oh, okay, I see we're using Cubetest to run end-to-end tests here, and that it even calls out the specific script that gets invoked to actually run that. And you'll see that Rob was using a similar script earlier when he was running it locally. So what does all of this mean, and what does having an image mean, right? What does this job being an image mean? So since we're running in a CI environment, which is a proud job cluster, and we'll probably need to have a show all about proud at some point. But since we're running in a proud job cluster, we have to actually have a container image to run, right? Because proud itself runs on Kubernetes. And this specific job is using Kubekins end-to-end. And you'll see that used in a lot of different places. So here we see that it's from Kate's test images. The image is Kubekins end-to-end. And we see this version tag here that looks like it incorporates the date, as well as potentially the branch that it's built from and a snippet of the digest. So where is that coming from? Well, let's see if we can find it. Kubekins end-to-end also lives in the test info repo, and we'll see in a minute what the implications of all these things living together looks like. But it is just an OCI image that's built from a Docker file by CI when changes are made, and you can go through here and look exactly at what's being added and that sort of thing. So you can see, let's see some of the things. So it looks like we have CFSSL. We are replacing kubectl, downloading a Go version, and some of these can be overridden by the arguments that are passed at build time. So importantly, build time is not the same as what we're seeing here at runtime. These are arguments that are passed at build time. And the other important thing, besides the fact that this adds things like Cubetest binary itself, as well as some things from the Kubernetes repo, is that this is built on a base image that also appears to be from the same GCR repository, and it's called Bootstrap, and similarly has a date digest tag here. So going back to our helpful guide here, let's take a look at the Bootstrap image. So once again, this is only one directory up and then over to Bootstrap. This is a separate image that is serving as the base image for Kubekins, as well as a number of other images in this repo. And let's take a peek at what's going in here. As you might guess from an image that's called Bootstrap, it does a bunch of the setup and installation of common packages that we may want across different, images that are built on top of it. So you'll see things like installing Python, common utilities, Google Cloud SDK, curl, common things here. So these are just different utilities that we're going to want to use across these different images. It also importantly adds things like entry point and runner, which we'll take a look at in a moment, as well as this scenarios directory. And scenarios are going to become very important here when we talk about the difference between Cubetest and Cubetest 2. But I want to look at entry point and runner, specifically entry point. So this is set as the entry point in the base, and we're not overriding that in the actual image built on top of it. So it'll serve as the entry point there as well. So you'll see if we look back at, let's see if I can find it. Here we go. We're not actually overriding the command, right, that the container is executing. So we're going to use that entry point and we're passing arguments to it. So that entry point that's set in the Bootstrap base image is being propagated up, if you will. And if you know more about OCI images, you might actually understand a little bit more what's happening there. But you can just imagine that it's being consumed as well by the next layer. So in this entry point, we have things like fetching the test info repo, and then running the runner.sh, which is also in this directory and gets added in the Docker file, and then executing Jenkins bootstrap.py. Bootstrap.py is a fun script that you will see lots of if you look at the logs of different jobs that are running, namely because if this loads here, it is taking its sweet time. There we go. You will frequently see bootstrap.py is deprecated. Test info on call does not support any job still using bootstrap.py. Please migrate your job to podutils. You will see this all over the place. And please do not use bootstrap.py if you can help it. But there are a lot of jobs that currently do use it. And there's a lot of folks working on moving off of it as well. But currently, it is a script that's being used. So it's important to understand what's happening there. It'll also inform, what the transition means and that sort of thing. Also, I want to take a quick moment. It looks like there's some questions in the chat here. Let's see. Ricardo asked about Cubetest and Cubetest 2. And it looks like we've already indicated that we'll answer that in a moment. Rob, if you want to take a peek at some of the other ones in there as well, feel free to answer those.
Yeah.
Cool. All right. Now we've gotten to the point where we know what kind of the entry point for this job is. And so now we're going to go down what I like to call the long winding path, because you basically go through a bunch of different things that are set up to create a certain environment to essentially do what Rob has done on his local machine. So the first step, as we saw, is bootstrap.py here. Once again, bootstrap.py lives in the test info repo. It's under the Jenkins directory for legacy reasons, and also a reason why we are no longer going to be using it. But there's quite a lot in here. But the important thing that is going to happen is it's going to choose from a set of scenarios. So if you remember in the Bootstrap image, we added that scenarios directory. And if we look in the scenarios directory, we have things like Kubernetes Verify, Kubernetes End-to-End, Kubernetes Bazel, and a couple of other things. You also see a very large deprecation notice here, suggesting that you do not use it. But basically, these are different ways to run a scenario of testing Kubernetes. So if we actually look in bootstrap.py, it's going to choose one of these scenarios based on arguments that are passed to it. And so here you'll see that when we get to the job script, we're going to pass in the scenario, choose from the scenarios directory which one it is, and then create that command. And we actually run that command. But how is it knowing that we want to use end-to-end tests here? Well, if we take a look back once again at the prowl job YAML, we are passing these arguments here to bootstrap.py. So timeout obviously is kind of self-explanatory. I believe that would be 70 minutes. Not actually sure what bear means, but we can look at the arguments. And then we're saying we want this Kubernetes end-to-end scenario here, which means that that's going to eventually get passed to the, let's see if I still have it up here. Scenarios, which is eventually going to be passed here. So we'll run scenarios slash Kubernetes end-to-end.py. All right, so let me close a couple of these windows here, and let's head over to see what's happening in Kubernetes end-to-end.py. Also, you can just look at the spoiler here and see that it's setting up an environment to eventually invoke Cubetest, which, once again, Cubetest is the same thing that Rob was running locally on his machine. And so basically in the end-to-end.py here, we have a number of arguments that can be passed. And you can take a look at all of them here. And you'll see that lots of these are going to match arguments that we passed here. So all of these are getting passed along to the scenario. And this is informing us that we want to use GCP to set up this cluster, which once again, this is a GCP Ubuntu test. So you'll see these different parameters that get passed through. And if we look in the scenarios, you can see things like different GCP args. Let's actually search and see if we can find some of them. GCP service account. Some of these are also going to get passed to Cubetest themselves. And let's see if we actually have Cubetest mentioned here. Yep, so we are going to pass a number of these to Cubetest. And I believe that, yeah, some of these are all going to Cubetest. So this test args here, this is similar to what Rob was passing. Rob was running a specific test. This one is using a regex to select some of those kind of bracketed categories that we saw earlier on test infra. And so those are getting passed along as well as some of these other ones. Importantly, I believe last show we talked a little bit about version markers, but we could probably have an entire show on that. But this is saying which version of Kubernetes we actually want to test and where we want to get it from. So this is essentially using the latest fast build, which basically means we're building it for a single architecture, in this case, AMD 64 Linux. And so this is going to go to a directory. And if you want to actually see exactly where that's happening, remember Kubernetes end-to-end.py is going to call Cubetest. So let's finally get over into Cubetest. And you'll see that for the different kind of plugins you can run for having a backing cluster to execute tests against, you'll see different directories for that. You'll also see this extract K8s, which is what's receiving that. Let's see. CI latest, you can see CI fast, and it is going to tell us where to actually pull the version from using some of these regexes here. And then based on the latest build, which is going to be a development version, we're going to download that version of Kubernetes and use it to bootstrap our cluster. So just like Rob was in that detached head state of the Kubernetes build, we're going to use a actual published build that if you're actually interested in where this is coming from, you can take a look at the build master and build master fast jobs on master blocking here, which are jobs that we covered last episode when we were talking about how we do some of our BuildX stuff with Docker. All right, so now that we are to Cubetest, we're going to eventually get to running this end-to-end test binary using Ginkgo. So once again, Rob said that we use the Ginkgo CLI to invoke these tests. The actual test suite itself gets compiled into its own binary called end-to-end.test. The node tests do a similar thing where I believe it's called node end-to-end.test. And if we actually, when we get back to Rob in a moment, look at his output directory from the different builds and look what's in there, we should see this actual end-to-end test binary there. And I want to show exactly where this is happening. So going back to Cubetest, and I believe it's in main.go here. We're going to find, let's see. Well, actually, let's just walk through the exact execution here. So when this gets invoked, we are going to see that it's going to parse some of the flags. And it's eventually going to do this new process control. And I believe this complete is what is going to actually execute it for us. Yeah, so it's going to go through things like acquire Kubernetes, check the version directory, and then based on the different flags you passed it, like up, down, etc., it's going to do a variety of things. Let me see if I can find the place where it actually invokes Ginkgo here. This is not the directory. Let's see. End-to-end go. This is likely where we're going to find it. Yep. Ginkgo parallel. Ginkgo flags. Here we go. So this is where we're actually running the command hack/ginkgo end-to-end.sh. Once again, we cloned down the Kubernetes repo. And so we have access to these different scripts, and we've made our working directory there as well. So this should work for us. If we look over at hack and Ginkgo end-to-end.sh, eventually what we're going to see at the bottom of this is actually running Ginkgo with the various Ginkgo args and the end-to-end test args, which these are all being populated from when we actually built it. And I believe there's an init directory, which is going to set some of these variables. But essentially, we're going to invoke that end-to-end test. And a lot of these are once again going to get passed along to Ginkgo. So basically, this is a whole path of going through passing arguments from one framework to the next. And as you can see, it's pretty complicated, right? There's a lot of different layers it goes through. One of the things that's helpful is actually going to the build logs, and we can kind of look at when it transitions from one to the other. So we're going to start off here with the bootstrap.py, obviously with the entry point. And you can see some of the setup it does. And then you can see here where we get to Kubernetes end-to-end.py and pass in some of these environment variables we want to be set, as well as some other args that we want passed along, such as the test args. If we continue to go down, you'll see that we're executing Cubetest. So once again, it went bootstrap, Kubernetes end-to-end.py scenario, Cubetest, and eventually, after we do things like downloading these different Kubernetes binaries, we are going to potentially get to creating the Kubernetes cluster. And I believe we're going to get to here. You can see all of the different scripts that are being run. So all of these are in that hack directory. So the first part was end-to-end up. So Cubetest up is actually translating to a script in Kubernetes. We're running that kube control script. And once again, this looks very similar to what Rob executed earlier or had previously executed. We are running to the end-to-end status script. And we are also eventually running this hack Ginkgo end-to-end.sh, which is exactly what we saw here in this hack script. And so this is going to execute the Ginkgo CLI and run that same exact thing. that Rob showed earlier on his local machine, but this is running it obviously in a GCE environment that we've bootstrapped. And you'll begin to see after some time some actual tests that are getting executed based on the different things that we focused and skipped in Ginkgo. So the last thing I'm going to talk about before handing it back to Rob is talk about Cubetest 2. So everything is moving over to Cubetest 2. And to be honest, I don't have a ton of familiarity with Cubetest 2, so we likely should have some other folks on to talk about it. But essentially what it looks like to me is being able to have a more unified and modular tool. So we're not passing arguments through this whole tree of things that are kind of loosely coupled. You can actually just tell from kind of looking at the directory structure of this repo what the goal is here. You can see that we have different kind of backing clusters. So an example here would be kind or GKE or GCE, which is what we're using in this case. And I believe someone in the chat asked about using kind to actually back your local cluster. Yeah. And so that's a great example.
So I did a bit of digging on that answer. So Rodolfo was asking, are we using kind when we use that script to bring up that local cluster? And a quick run through of the script would say no, we're not using kind. And I would imagine that it predated the existence of kind. Don't know for a fact though, so so don't quote me on that. But obviously here, if you look at the help output from the local up cluster, you just see a page and a half flags, and obviously, like you say, this is an attempt to modularize that in terms of the backends, as it were, that are providing a Kubernetes cluster.
Yeah, that's exactly right. And the way that the Kubernetes cluster is getting bootstrapped locally for Rob's local machine is actually in that cube up script. So if you want to look at exactly what's happening, but it's actually running the Kubernetes components, right, as opposed to having a unified thing like kind. And another thing I'll mention here for Cubetest 2 is we have these different testers as well, so you can swap out Ginkgo for other components as well. So this is definitely something to take a look at here. And if you want to see actually the design of this and migrating things off of bootstrap.py and Cubetest, you can look at the CI migration KEP, which is a more detailed rundown of what some of the goals are and what the proposal is. And then you can also see that this is starting to happen. So there's folks that are working on this as we speak. And here's an example of a GC conformance job, which is on SIG release master blocking, which basically means that it is critical, right? We would block a release if it was failing. And this was actually recently merged to switch over from using the previous job, which was using Cubetest, to the actual Cubetest 2 variant of that and making that the primary. And moving that onto SIG release master blocking. So definitely enhanced confidence in Cubetest 2 is coming. So it's exciting to see some of this switch over happening. So yeah, I hope that was helpful in kind of going through some of the layers and also just illustrating potentially that, it is complicated and we're trying to improve that. So it's not quite as complicated for folks, but hopefully going through that can kind of give you an idea of how to troubleshoot when you see things. And I'll pass it back off to Rob to close out with anything.
Yeah, sure. I suppose one of the things to note is that work has been done on podutils to make it a complete replacement of Bootstrap. And I think you might know this better than I, Dan, but there was an issue around metrics or logging or something that podutils was lacking, and I think that's in the last couple of months that's been fixed. So the time to move away from using bootstrap.py is pretty much now, and I think it's possible to do it now. And whatever the feature was that was missing podutils, I think they're equivalent now.
Awesome. That's great to hear. Rob, was there anything else you wanted to show on your local machine or anything else you wanted to say before we wrap up?
Yeah, I don't think so. Other than to say that it's still running to try and make it fail, So, so I I think in my notes, so the big blurb that I put in is linked off the main HackMD, and because I didn't want to pollute the HackMD with the mass of text. I think it would have taken down HackMD, to be honest. Um, so so yeah, I think that's pretty much it. Unless there's any other questions that you have, or if you think there's anything I've
No,
missed.
I don't think so. It's definitely super helpful to see those
Yeah.
executing locally. And I think maybe next time, well, if there's a good candidate for an actual test that we show a fix to, that could be a good one. But we both looked into a
Mm.
little bit of the Node end-to-end test as well. So maybe doing kind of like a sibling show to this one, talking about how Node end-to-end tests get run. They're a little bit more mystical to a lot of folks because it's a little bit more hidden from end users a lot of times. So I think that would be
Mm.
a great one to look at. But this has been a super helpful show for me personally, and I hope for some of the folks that are watching and some of the folks that watch this in the future. But if anyone has feedback for us about other things we can cover, how we can improve our delivery here, um, definitely feel free to reach out afterwards in Slack or on Twitter or anything like that.
There is one thing that we missed that we spoke about in our tech rehearsal, which is what is Kubekins and where did it get its name? And so I asked Dan this, and Dan goes, "Well, I don't know." And he asked in SIG testing, and Kubekins is a portmanteau, the mashing together of Kubernetes and Jenkins. Jenkins used to be used as for CI on Kubernetes back in the day, but not some more, but not now. So our CI job runner, like Dan was saying earlier, is Prow, and uh, and we don't use Jenkins, but there are artifacts of the time when we used to use Jenkins, and Kubekins is yeah, uh, that's a portmanteau of Kubernetes and Jenkins.
Yep, and that's a little Kubernetes history for y'all to finish up your week on. So maybe we'll make that a recurring segment. I like that. But
Yeah.
yeah, thanks again for everyone for tuning in, and thanks to Jeff as always for running the stream. See you, folks.
See, bye bye, everyone.